Alright, so just like yesterday, today we're going to focus on graphing. We are going to look at some stuff on the graphing calculator again. We're also going to graph by hand. So in example 1 and 2, we can see that these are in standard form, not slope-intercept form. So the only difference is that if they're in standard form, you can't really compare the slopes easily. So you have two choices. We can do what we did on the back of the homework, which is to rewrite all of the equations in slope-intercept form, or you can graph them and see if they're parallel or intersect. And if you graph them from this form, then you would want to graph the x and y intercepts and connect the points. So just for good practice in number 1, I'm just going to graph one of them using the x and y intercepts and the other one using y equals mx plus b. Okay, so this graph here is going to be much easier to graph using y equals mx plus b than the x and y intercepts, because if you find your y-intercept, you're going to end up with a fraction. So we'll solve this equation for y. So you get 3y equals negative x plus 2. Divide everything by 3, and we get negative 1/3 x plus 2/3. So again, you can see I have that awful y-intercept of 2/3. So if you were to plot your x-intercept, meaning you set y equal to 0, the x-intercept gives x equals 2. So if x equals 2 and y equals 0, that's the point 2, 0. So you could actually start your graph with the x-intercept instead of the y-intercept and apply your slope from that point. So sometimes if I get a gross fractional y-intercept, I try to find a point on the graph that is nicer. So you don't always have to start your graph at the y-intercept. It's just something we sort of show you in Algebra 1 and geometry because it's easier. But then now you could take your x-intercept and go down 1 over 3, or up 1 and left 3. And then connect your points, graph your line. And then we'll graph our other line. So for this one, I told you I'm going to graph both my x and my y-intercept. So when y is 0, x is negative 2. So that's the point negative 2, 0. And then when x is 0, y is also negative 2. So that makes the slope of this line what?
1.
Negative 1, yes. So it's going down 1, right 1, down 1, right 1, etc. So what we should notice is that my two graphs will intersect at the point negative 4, positive 2. So if they intersect at the point negative 4, positive 2, these are intersecting, independent, one solution. Intersecting, independent, one solution. Good? Number 2. So this one isn't terrible to solve for y, and the slope and y-intercept are rather nice. So the top equation is y equals negative 2x plus 5. So you plot your point, positive 5. Go down 2 and over 1. And what you'll notice is I plot a lot more points, although my computer's kind of being glitchy, than I used to. The reason I'm plotting so many of these points is because if you're going to solve this system by graphing, you need to make sure your graph is really accurate, meaning that you find the exact point of intersection. So like here, I needed my graph to be accurate to see that point of intersection. Okay, graphing the other curve, we have negative x plus y equals 2. So again, you have two choices. You could do your x-intercepts or your y-intercepts, or you could solve for y equals mx plus b. So if you solved, you had y equals x plus 2. If you found your intercept, you had negative 2 and positive 2. So again, I have intersecting lines, and they intersect at the point 1, 3. How could I check that the point I get is correct? What could you do? God, what do you think?
Plug it back into both equations.
Yeah, so if I plug it back in, both equations should equal 3 for y. So you could do is plug in 1 for x. So 2, 1 plus y equals 5. Subtract 2 from both sides. You get y equals 3. And here, negative 1 plus y equals 2. So again, add your 1 over, and y equals 3. So what you see is that when you plug that 1 in, at least there's a calculator in IRFM, you get y equals 3.
Unless some calculators are pretty expensive.
This is true. All right. So for number 3, many of you actually figured out yesterday to turn your stat plots off. Today we might be turning them back on to look at this example. So they give you a data table, and they give you 2 people. What they don't give us is their linear equation. So what we have to do is compare their lines of regression, and we're going to use the graphing calculator to find the point of intersection. So did you take both of those?
No, I'm getting rid of those 2.
I know, but I was going to use one.
Oh. Here,
Do you two not have graphic calculators?
No, I do.
Did you never sign them out at the beginning of the year? Charged it.
No, yours.
Mine's dead, yeah. All right.
You could put it on the charger while you're using it.
I'm good. All right. Oh, her stuff is. So you want to go to your lists.
List?
Yeah, so you can edit your data. Like L1, L2, L3, your lists.
Oh, I didn't think that's what you said.
So week 1, week 2, week 3, week 4. Type in ed. So he's 50, 55, 63, 67. Go to stat, go to calc, go to option 4. Now I'm going to store my equation in my graphing calculator because we're going to use it to find the intersection. So you're going to hit the word vars right here. Then you're going to arrow over to y vars. enter on function, and put in y1. So vars, arrow over to,
Are we putting in the third column too?
no,
Just 1 and 2?
because you guys don't know how to change these.
Wait, where do
And
I
it
go
will
on
like,
bars?
so I'm just gonna have you do it once, then do it again.
Where do I go?
So you go vars, go over to y vars, enter function, enter y1. And then you go down to calculate.
Wait.
What the heck? Var,
Maybe pay attention.
stat,
Alright, she has
count,
nothing in there.
or,
I think.
oh, do you go to store regression?
Under store regression,
Yeah.
you're gonna hit vars, y vars, function y1, so that it will put this equation in your y.
That's the problem.
One.
I wasn't, I got it. I wasn't under the thingy. I wasn't under store.
Got it. So now that equation is stored in my y1.
How do you put that in there?
Oh my goodness.
Yeah, now
You
what
can
do you-
listen on the next one.
What do you do now?
Go back to edit.
Wait, no, but I'm here.
Just hit calculate.
I found it. Now what?
Oh, and then you'd store the next one on Y2.
Yes.
Now wait, now what do I do?
Alright, go to edit.
Edit.
Enter your data in L1 and L2. This time in L2, I'm gonna put Joe.
Joe.
So 40, 47, 56, 62. We good?
Yeah. No.
Okay. Hit stat, just like we did before. Go to calculate. Go to option 4. None of that is new.
Yeah.
The only thing I'm teaching new is now in the store reg EQ, which means to store the regression equation. That's what it means. We're going to hit the word vars. You're going to go over to y. Go down to function. This time, select y2. Because if you click y1, it's going to replace the equation you already put in there. Go to calculate. So my slope is 7.5, my y-intercept is 32.5. So both my equations are now stored in my y equals.
I got it.
Now, you need to graph this. So the best way to graph it is to go to zoom and go to stat
Where the heck is
so that it kind of matches the data. Ooh, that did not.
Zoom stat?
Yeah, but it should have graphed it to fit the data.
Zoom fit.
No, zoom fit would graph it to fit the lines. Stat's supposed to match your data.
I got it.
Yeah, I mean, it's all going to graph, but what you need to do is see the intersection.
It didn't show me the intersection. Yeah, it doesn't.
I don't know. That's what I said. It doesn't, it's not.
Why does it show it on yours?
I hit a different, I hit a different zoom. Okay, if you go to window, we can't have negative weeks, so I'm going to change my x min to 0.
Oh crap, all mine is messed up from the start.
I'm going to change my x max to 15. I doubt it's going to take more than 15 weeks. You can look at their numbers over here, and they're in like the 50s, 40s, 60s. So I'm going to make my y values 30 to, I don't know, 100's fine. All right, now are the 4 of you going to know how to change your window? I'm moving up. Okay, graph.
Bang.
So now the two graphs intersect. In the past, we would do it by hand, but since we can't get an intersection with like decimals and all of that by hand, you're going to hit second trace. You're going to go to option 5, which is intersect,
That's nifty. Whoa.
and you're just going to hit enter 3 times.
Right through.
Because you're guessing for the blue graph, guessing for the red graph, and guessing in general.
I think I got it.
And you see that the intersection is at 7.1875, and the y value is 86.4025. So what that point of intersection means, x is the weeks, so during week 7, both Ed and Joe will sell between 86 and 87 shoes. So right now, if you look, Ed's beating Joe, but Joe's catching up. So at week 7, they will sell the same number of shoes, which was question B. Use the graphs to predict the week, so it's week 7, that they sell the same number of shoes. So during week 7, they will both sell around 86 to 87 shoes.
How do we answer part A?
That's the equations you put in y1 and y2. There you go. How's my coffee?
What's the X max?
I did 15, but if they intersect at 7, 10 would work, 12 would work. You're making a prediction. It doesn't have to be precise.
What's the Y max?
40,
What's the Y max?
100. Alright, so during the winter games, we can compare men's times to women's times. Men have typically been faster than women due to the fact that their legs are longer, they are taller, they have longer shin bones. Oh, do you not have the Olympic one? Alright, we'll move past. That one was kind of icky. Can I see your packet? Did I just put your homework next? I might have. Let's graph then those next 4 problems.
Is this homework?
No, that's the rest of our notes. Let's do it by hand.
Is it quicker to do by hand?
Than on a calculator? It truly depends on your skill set. So like, if you're good on a graphing calculator, then you might think it's quicker to graph it on a graphing calculator. If a graphing calculator is an area that you struggle with, then doing it by hand might be easier for you. It really just kind of depends. Alright. So what we're going to do is graph our equations. So we have 2x minus y equals negative 1. So again, I have a tendency to write them in y equals mx plus b form. So for this one, I could add my 1 and add my y. So y is equal to 2x plus 1. And then over here, 2y equals negative 5x minus 16. So y equals negative 5 halves x, and 16 divided by 2 is 8. So plot your y-intercept and apply your slope. So your y-intercept is 1, your slope is 2. And like I said, these graphs, you kind of have to give more points than we did in the past, because you really want to make sure you can see the point of intersection. This graph is at negative 8, and it goes up 5 and over 2. And what's nice is if you do one graph really nicely, then the other graph, you only have to really graph it till you see where they hit each other. So the solution to this equation is the point where they intersect, which is right here at negative 2, negative 3. And the order you write them matters because it's x comma y. It's an ordered pair. we're saying x is negative 2 and y is negative 3. Okay, number 6. 3x plus 2y equals negative 2. So subtract your 3x, 2y equals negative 3x minus 2. Divide by 2, and you have negative 3 halves x minus 1. Plot your y-intercept. Go down 3 and over 2. And then again, in the next one, add your 4x. Divide by negative 4. Or divide by 5, rather. So again, you see that you have a really gross y-intercept. Now what's nice on this one is the x-intercept. And I can see that because I have negative 4 and negative 28. So I'm going to plug in y equals 0 to get my x-intercept. And I have negative 4x equals negative 28, or x equals 7. So instead of starting my graph at negative 28/5, I'm going to start my graph at 7, 0. And then I'm going to go down 4 or up 4, and then right 5 or left 5, depending on which direction I want to go. Ew. They not intersect on your graph either.
They intersect on mine.
What did I
You're
do?
doing it.
Oh, I'm so silly. What?
You're in a negative slope.
Yeah, I said I went the wrong way. I don't know why. I was upside down. To negative 4. Okay. So again, your choices are pretty easy. You can do x-intercept, y-intercept, or rearrange your terms. How many of us like rearranging the terms? How many do x and y-intercepts? Okay. How many didn't fit? How many find this lesson easier than piecewise?
Oh, I guess I'm. Oh, heck yeah, if you do a piecewise.
Yeah. Yes. Way easier.
I still don't know how to do a piecewise.
Well, you know the whole left hand.
I know.
Yep. Who said that? Good.
It's in their solution, right?
Correct. So since the slopes are the same, the lines are parallel, therefore the solution to the graph is none. Parallel lines do not intersect, therefore no solution.
Do we even have to graph it if we see this?
Yes.
The same line?
Yes. Okay, and then the last one, if you solve and simplify this equation, you get y equals negative 3x plus 6. You started with y equals negative 3x plus 6. So for this one, the graphs are identical, which means that my solution is perfect.
Infinity and beyond. I didn't think such a person. I'm not virgin.
So your homework is just the front and the back on that next page. So it's 6 graphs. Because I knew today was a little bit longer of a lesson. Yes.
Go back to